The number n of bacteria present in a culture at time t in, and notice it's going to be in hours, obeys the law of uninhibited growth. And they've going to give us the formula, namely n of t is equal to 1,000 e to the 0.01 t. And notice that k is 0.01. That means that it is growing. It is growing. T is time in hours. And n of t, is the number of bacteria. And then it asks us a series of questions. It gives us the formula. Yay! It gives us the formula. And then we have to determine the number of bacteria at t equals 0. That's the beginning of time. How many bacteria did I start out with? That's essentially what it is. So that's my baseline. What is the growth rate of the bacteria? What is the population after 4 hours? When will the number of bacteria reach 17,000? When will the number of bacteria double? And so you need to understand you have two variables. You have n of t, which is y, and then you have t, which would be the equivalent of x. If I'm using my grapher, I'd have to make all of these guys x's and y's. So that says I either put in x and get out y, or put in y and get out x. If it's the number of bacteria, that's a y value. That means I'm putting in y. If it's a time, like 4 hours, that means I'm putting that in for t, right? So it says at t equals 0, I am given a t value, and I need to find the y value. That says that n of 0 equals 1,000 e to the 0.01 times 0, which is 1,000 e to the 0. E to the 0 is just 1, which is 1,000 times 1, or 1,000 bacteria. So in the beginning of time, I started out with 1,000 of these suckers. 1,000 were present. To me, when I think of bacteria, I don't think of counting 1, 2, 3, 4, 5. Oh, there's 5 bacteria. To me, there's gazillions of them. And so we have this is 1,000. Now, what is the growth rate? And this can throw you, but you got to remember this: K is the growth rate, which means that K is, in this case, 0.01, or it is 1%. What's the time? Per hour, right? So the growth rate is 1% per hour. So that decimal really needs to be transferred into a percent with the time unit. So that says I've got 1,000 bacteria that's growing at a rate of 1% per hour. So K is the growth rate. And of course, the bigger K is, the bigger the faster we're growing, right? And it says, what is the population after 4 hours? They give me a time, namely t equals 4, or that n of 4 equals 1,000 e to the 0.01 times 4. And then we pour a handy dandy little calculator. Yippee-yay. So it's 1,000 e, which is above natural log, to the 0.01 times 4. This is pretty print, which is kind of nice. And I've got 1,040.8 bacteria. Or you could say what? Either approximately or approximately 1041 bacteria. Or you could say, theoretically, I really only have 1,040, right? Because you don't have 0.8 of the bacteria. But that's what my model is telling me. And it says, when will the bacteria reach 1,700? When means time. And I want to know the time. And 1,700, at your y value, that's n of t. So I want to know when e to the 0.01 t equals 1,700. And I've got to do 1,000. I forgot that guy. Now what I need to do is get e by itself, so I need that exponent, so I need to bring that exponent down. So the first thing I want to do is divide everything by 1,000. So the e to the 0.01 t equals 1.7. And now from this point on, all of these problems get worked the same when you do this. And what do I need to do? I need, because this is e, I'm going to take the natural log of both sides. So if the two things are the same, then the natural log of the two things are also the same. Bring down the 0.01 t, natural log of e equals the natural log of 1.7. And since natural log is base e, natural log of e is, what's the natural log of e? 1. I'll come back up here. ln e is log base e of e, because the base on the natural log is e. And that makes that 1. So that t is the natural log of 1.7 divided by 0.01, or t is approximately, and now again I bring in my handy dandy little calculator, natural log of 1.7 divided by 0.01. That's not right. Oh, times the fat. No. Yes. 53.06 what? What's the units? No. What's the units? I'm finding t. What's time t represent? Time. So it would be hours. Very slow growing bacteria. Very slow. Well, it depends upon the bacteria. Could be a good bacteria. There are things called good bacteria. But if it's a bad bacteria, you want it slow. If it's a good bacteria, you might want it faster. When, that means time, will the bacteria population double? Double means how many bacteria am I going to have? I'm going to have 2,000, right? Start out with 1,000, I end up with 2,000, so I want to know when is 1,000 e to the 0.01 t equal to 2,000. Again, divide both sides by 1,000. So e to the 0.01 t equals 2. And we know the drill, right? Take the natural log of both sides. So 0.01 t, natural log of e, is the natural log of 2. And then we know the natural log of e is 1. So the t is 2 divided by 0.01. And so now I'm going to take up, what did I forget? Natural log of 2. That makes a difference. So natural log of 2 divided by 0.01 is 69.3. What? Oh, where's she at? So to double, it's going to take 69.3 hours.